Let's take a look at page 2. Question 1 says, the SAT is an exam used by colleges and universities to evaluate undergraduate applicants. The test scores are normally distributed. Very good. So we have normal distribution. In a recent year, the mean test score was 1,475 and the standard deviation was 308. The test score of 4 students selected at random, and they found those scores to be 1,930, 1,340, 2,150, and 1,450. Find the z-scores, then check to see if any of them is in the tail or are they unusual or not. Very good. Let's see what do we have. So for this question, we have the following scenarios. Question 1, page 2, SAT scores. So first of all, we have the mean. All right, the mean is given to us. The mean is equal to 1,475 with the standard deviation, which is 308. The very first student score, x sub 1 is equal to, let's see, 1,930. The second student is 1,340. The third student score is 2,150, and x sub 4 is the fourth student, 1,450. Very good. So these are the scores that we have, and we want to know which one is an outlier. Which one is an outlier? Or which one is in the tail? So we need to convert each one of these into z-score and check to see if it's an outlier or not. Remember that the transformation that we're going to use is z equals to x minus the mean divided by the standard deviation. We take each x value, we plug that into the formula, and we find the z corresponds to that x value. So let us start. Here you have z sub 1, which is equal to, your x is 1,930 minus the mean is 1,475 divided by the standard deviation, which is 308. So this is 475. And let us do the calculation. If you plug in x 1,930 into your machine, into your transformer, it's going to give you about 1.48. So the z-score associated to this score, 1,930, is 1.48. What about the second one? Z sub 2 is equal to, what is your x? X is 1,340. Minus what? The mean, right? Mean is just right here, 1,475 divided by the standard deviation, which is 308. Well, it gives us negative 0.44. Okay, this is the z-score associated to 1,340 score. What about the third one? What is z sub 3? Z sub 3 is your x, which is 2,150 minus the mean, 1,475 divided by the standard deviation, which is 308. This is 308. So it gives us approximately 2.19. Okay, this number is outlier. This score is outlier. Let us take a look at Z sub 4. The fourth Z-score, your X is 1,450 minus the mean 1,475 divided by 308, which gives us approximately negative 0.08. So remember the behavior of our standard normal distribution. This is our standard normal distribution. The mean is 0 with standard deviation 1. And remember that on the right-hand side of 0, you have 1, 2, 3, and the rest of the numbers, -1, -2, and -3. Toward the tails, the outliers are larger than 2. And if they are larger than 3, they're going to be highly skewed, and it's going to be highly unlikely. So as long as you have numbers larger than 2, less than -2, you are dealing with outliers. So take a look at this. Among these 3 Z-scores, the very first one, the second one, the third one, and the fourth one, the only outlier is 2.19, or the score associated to it is 2,150. This guy is the outlier. Let's take a look at question 2. Let us read the question carefully, then start answering the question. So the question says, the ACT is an exam used by colleges and universities to evaluate undergraduate applicants. And the test scores are normally distributed. Okay, it means that we are allowed to use normal distribution formulas. In a recent year, the mean test score was 22.2 and the standard deviation was 4.9. The test scores of 4 students selected at random are 16, 24, 9, and 35. Question says find the Z-scores and determine whether any of the values are unusual or not. Okay, let's write down the information that we have. Question 2. The mean given to us is 22.2 with the standard deviation, which is 4.9. X sub 1 is equal to, let's see, 16. X sub 2 is equal to 24. The third score is 9, and the fourth score is 20. It's 35. Okay, very good. So we're going to use our transformer Z formula. Z equals to X minus the mean divided by standard deviation. Remember that we're looking for numbers larger than 2, less than -2, to consider as outliers. So Z1 is equal to X, which is 16, minus the mean, 22.2, divided by your standard deviation, which is 4.9. It gives you approximately -1.27. The second score is 24. So Z sub 2 is equal to X, which is 24, minus the mean, 22.2, divided by the standard deviation, 4.9. Approximately, you get 0.37. Z sub 3 is 9 minus 22.2 divided by standard deviation, 4.9, which is approximately -2.69. Okay. And finally, 35, Z sub 4 is equal to 35 minus 22.2 divided by 4.9, which is approximately 2.61. Again, let us remember how to deal with outliers, unusual values. So for a standard normal distribution, we have 0, 1, 2, 3, -1, -2, -3. Toward the tails, you have unusual values or outliers. Let's make it a little bit symmetric. So left-hand side and right-hand side be a little bit similar to each other. Okay, here we go. So numbers less than -2, numbers larger than 2 are assumed to be unusual values. Okay, so between these four numbers, -1.27, 0.37, -2.69, and 2.61, of course, 2.61 and -2.69 are unusual values. So you're going to say that, hey, the score 9 and the score 35 are unusual scores in this collection. So x equals to 9 and x equals to 35 are unusual. So the student who got 9 didn't study at all, or the student who got 35 studied very well.